In this course, you will learn all about infrastructure as code. I'll start by giving you a general overview of the different concepts, and then I'll show you how to implement infrastructure as code with 3 different labs. This course will use Python and AWS, but the concepts will apply to other languages and cloud providers. So let's start by talking about what infrastructure as code is. To put it simply, it's setting up your infrastructure as code. By infrastructure, I mean all the different things needed to deploy your software into a cloud environment. That can mean things like virtual machines, containers, or serverless functions. Infrastructure also means all the other pieces of infrastructure you need to set up to make that successful. That can be security, like AIM and KMS, or networking, or some of the monitoring and logging capabilities. You can also use code to configure and set up data stores. These are the things that your application needs to store and manage data. The last piece of infrastructure landscape is the applications themselves, and getting the applications that we're building into the infrastructure. All of these different pieces of infrastructure can be set up using code. Software as a service, or SaaS, is related to infrastructure as code. Software as a service allows users to connect to and use cloud-based apps over the internet. SaaS provides a complete software solution that you purchase on a pay-as-you-go basis from a cloud service provider. You rent the use of an app or software for yourself or for your organization from a cloud service provider and connect to it over the internet. Common examples are email, office tools, CRMs, and development tools. Infrastructure as a service is part of software as a service. Infrastructure as a service is a cloud computing service where companies rent servers for compute and storage in the cloud. This allows users to run operating systems or applications on the servers without the maintenance and operating costs of those servers. So infrastructure as code involves using code to manage your infrastructure as a service. It's becoming more and more important to automate infrastructure because applications can be deployed to production up to 100 times per day, and you don't want to be doing that all manually. It's also helpful for infrastructure to be provisioned or deprovisioned in response to load. We need to answer questions such as, how do we get the images for our VMs? How do we get the container images in? How do we package up and ship code into serverless functions? Over the years, there has been a transition with how people are using cloud infrastructure within their organization. In the first wave, it was fairly simple. The infrastructure were fairly static. It was often single virtual machines that you just access through SSH. It got a little more complex in the second wave. There were more containers and people started using provisioning tools to specify the application behaviors. People used things like Docker and Datadog. Modern cloud infrastructure has added way more complexity. It uses containers, serverless, and more managed services as part of the applications. There are now way more different pieces involved in how people build the infrastructure. Infrastructure as code is becoming a more important part of how people build and deliver applications because infrastructure as code is what describes the glue between all the different edges on these diagrams. This diagram for the modern infrastructure may look more complicated than the previous ones, but it can actually be easier to maintain. A key benefit is that the dark gray squares in the diagram are the only part which is the code you own. And that part is smaller than the previous ways of doing things. So a lot of the operational burden has been decreased compared to how it used to be done. With infrastructure as code, it is now easier to build, deploy, and manage infrastructure in a repeatable and scalable way on a variety of cloud service providers. Infrastructure as code makes it easier to manage that process alongside your actual application code. Now there is a greater focus on the glue between the different services that are being managed by a cloud provider, and these services can be deployed in a repeatable and scalable way. Infrastructure code takes on an increasingly more important role in how you manage everything in the modern cloud. So here are the 3 main ways that can be used to manage all the resources. Manual, That's how it used to always be done. You just point and click to create or modify resources in the console. You can do it like through the AWS console. You can just point and click to what things you want to create. Then there's ad hoc automation. This is when you use CLI commands or scripts to create and modify resources. So you're kind of using some code, but it's not going to be able to be reused over and over and modified very easily. The third way is what we're talking about, infrastructure as code. There's provisioning, which is declaratively creating and modifying resources, and configuration, which means to change the state of an existing resource post-provisioning. Infrastructure as code gives us the ability to write down what we want the desired state of our infrastructure to be. I'll be showing you how to do some of these things later. There are a few different ways to write infrastructure as code. So one approach is to use JSON. Here's an example. You can see this is a way to tell AWS what resources you want to have. You can see the resources, the EC2 instance, the instance security group, and just everything you're going to need just in a JSON format. Another method is to use domain-specific language, or DSL. This is a custom method specific to the tool or cloud provider you are using. So here's an example. You can see it does kind of look like code, but it's it's not like a popular programming language or even the exact way that JSON usually is written. Yet another way of defining infrastructure using code is to use a well-known programming language. For instance, Pulumi can be used to write infrastructure as code using TypeScript, JavaScript, Python, Go, and .NET. Here's an example using TypeScript, and later we'll be using Python. Using code gives the ability to do things that are not possible in some of the other methods. In this example, there's a for loop that creates an instance for each availability zone. Code gives the ability to use loops, conditionals, classes, packages, and more. Using popular programming languages also allows the use of common IDEs, linters, and test frameworks. So let's get into some real-world examples. We're about to set up some actual infrastructure as code. There are a few different services that allow you to use popular languages to create infrastructure as code. In this course, we'll be using Pulumi. This course was made possible through a grant from Pulumi. Pulumi is an open source infrastructure as code tool for creating, deploying, and managing cloud infrastructure. Pulumi works with traditional infrastructure like VMs, networks, and databases, in addition to modern architectures, including containers, Kubernetes clusters, and serverless functions. Pulumi supports dozens of cloud service providers. We'll be using Python and deploying on AWS, though it can be done with other programming languages and cloud providers. We'll start with a simple example. This will show an end-to-end experience of working with Pulumi using very simple resources. In this first example, we'll do the following. Create a new project, configure AWS, provision infrastructure, update infrastructure, make your stack configurable, create a second stack, and destroy the infrastructure. We'll use an S3 bucket and then work through the lifecycle with a simple set of resources. Then in future examples, you will learn how to implement more complex things. With Pulumi, infrastructure is organized into projects. Each project is a single program that, when run, declares the desired infrastructure for Pulumi to manage. Before we start the first lab, make sure you have Pulumi installed. The way to install is different depending on your operating system. You can check the link in the description for all the instructions for how to install on different operating systems. One way, if you have Homebrew, is just brew install Pulumi. Like I mentioned, we'll also be using AWS. You have to make sure you have an AWS account and have the CLI set up and authenticated. I have a link in the description that shows you how to sign up for a free AWS account. Also, there's another link that shows how to install the AWS CLI for your operating system. From AWS, you're going to need an access key ID and a secret access key. Let me show you how to get that. I'm at this URL right here. You can do it without the v2 at the end, just the console.aws.amazon.com/IAM. And then I'm going to go to users here. And then I'm going to add a user. I'm going to make a new user just for this project. And the user is just going to be infrastructure as code, or IAC. And I'm going to click that I want to get the access key here, and next permissions. I'll just add administrator access, so to make sure it can do whatever it needs to do. And then I'll just go through, just keep clicking next, and then create user. Okay, now we have the Amazon access key and the secret access key. So you're going to actually have to copy the access key and the secret access key from this page. And you can get that obviously by clicking show to show the secret access key. Let me show you where you're going to need those things. Go over to your command line and type in AWS configure. Okay, now this is where you're going to enter your access key. I'm just going to copy it from here. And then the AWS secret access key. Now yours probably won't have this here because I've already done that. So it's seeing if I want to use the one I already have, but I want to put in a brand new one here. And then we can just click none for the next few things here. Okay, AWS is set up. So the first step to starting a Pulumi project is to create a new directory. Each Pulumi project lives in its own directory. So I'm going to create one. First I'm going to go into projects. Okay, I'm going to make a directory. And I'm just going to call it IAC Lab 1. Now I'll just jump into my directory I just created. Okay, I'll do Pulumi new Python because we're making a Python project. And we'll just select yes to everything. Now I've already used Pulumi on this computer, but if this is the first time you've used Pulumi, you will be directed to enter an access code or log in. And it will tell you the website to go to get the access code, but it's app.pulumi.com/account/tokens. You will have to create a Pulumi account, and then you will be able to get your access code. So this command has created all the files we need. It's initialized a new stack named dev, which is an instance of our project. We now need to install our dependencies as part of our virtual environment. So let's set up our virtual environment. We're going to create our virtual environment and install the required Python packages. The Python module used to create and manage virtual environments is called venv. So let's use these commands. First we'll do Python 3 venv, and then source venv/bin/activate. Okay, I've activated my virtual environment. And now I'm going to install the requirements. pip3 install our requirements.txt. That requirements.txt file was created when we initialized our Pulumi project. Now let's open this up. I'm going to open it up in Visual Studio Code, but you can use any code editor you want. Okay, these are all the files that got installed when we did our Pulumi new. This main.py is the program's main entry point file. This is the file that we'll be putting all of our code in. Now we have the requirements.txt. That's just your project's pip dependency information. And then we have Pulumi.yaml, which is the project's metadata containing its name and language. You can see we have Python, and then we have the name here and the virtual environment. So if we go back into the main.py, we'll notice that we just have one line of code that's just automatically put in there, which is import Pulumi. Now, there could be more or less code in here depending on which way we run the Pulumi new command. But we just ran it with Pulumi new Python, so it just started with import Pulumi, which is a line of Python. So now that we have the basic project, let's configure AWS support for it. I'm actually going to open the terminal right from within VS Code. Okay, I'm going to install something. So pip3 install Pulumi AWS. Now I'm going to make our code take up more of the room here, and I'm going to add another line. So I'll import what we just installed. So import Pulumi, and it actually recommends it right here as AWS. Okay, now we're going to configure an AWS region, which is whatever region you want to deploy to. We're going to run something in the command line. So I'll go back down to the command line, and I'm going to do Pulumi config set AWS region, and you can use any AWS region that you like, but in my case, I'm going to use US East 1. Okay, now we're actually going to start doing some infrastructure as code. We're going to provision infrastructure. So now that we have a project configured to use AWS, we'll create some basic infrastructure. We'll start with a simple S3 bucket. So let's declare a new bucket. Right up in our Python file here, I'm going to say bucket equals a aws.s3.bucket, and then you can call anything you want, but I'm going to call it my bucket. Okay, I'm going to save this, and we're going to preview the changes. So I'm just going to go back to my terminal down here and type in Pulumi up. So Pulumi up is the command you'll be running a lot with Pulumi, which is going to basically run our main.py file and set up our infrastructure how we configured it. So it looks like there's an error here, so let's see what that is. It looks like there was a mistake with my AWS login. Let me just try doing the login again and see if that fixes the problem. AWS configure. Now I'm going to get my access key. Now I'll try running Pulumi up again. Okay, it worked this time. So let me bring up this so we can see more of what the output was here. So this is a preview. The command evaluates your program, determines the resource updates to make, and shows us an outline of these changes. So this is what's going to happen. We're going to create this stack, and we're going to create this bucket here. And it hasn't done anything yet. We can decide what we want to do. For now, I'm going to go to details to see more details. So you can see now, we can see that the ACL is private. You can see the actual bucket name. We called it my bucket, but Pulumi is going to add this at the end. So we can actually create a bunch of buckets with the same name, but it's just going to have a different thing at the end here. And you can just see some extra details about this. And I do want to perform this update, so I'll just go to yes and okay, return. So now our S3 bucket has been created in our AWS account. So if we view our buckets on the AWS website, you'll see the new bucket. So I'm going to go to AWS and then go to the S3 section. And it's going to show this bucket we just created. So it's currently empty, but we can see the bucket that we just created with Pulumi. And there's also this URL here. If we go to this URL, I'll just do command click. And I'm going to have to log into Pulumi to get this to work out. So now we're on the Pulumi console, which records your deployment history. So right now we've just done one thing, so you can see one thing on here. Okay, next I'm going to show you how to export your new bucket name. So we're going to go back into the code area, and to inspect your new bucket, you'll need its physical AWS name. Well, we were able to see the name up here when we went to more details, but there's another way to get the name that I will show you using the code. So this is called the logical name, my bucket, but like I said before, the AWS name will be a little different. Programs can export variables, which will be shown in the CLI and recorded for each deployment. So let me show you how to export the bucket's name by adding a line of code in here. So right after we get the bucket here, I'm going to do pulumi.export, export, and then I'm going to export the bucket name. So that's just what we're calling this value, which we're going to get as bucket.bucket. So this bucket.bucket will be the bucket name. So let me just save this, and then we'll go back into the terminal, and I'll do Pulumi up. And now we can see there's a new line here, outputs. So you can, in your Python code, you can export certain information that will show up in the output section when you do Pulumi up. So I'll just select yes to perform the update. And you can see it's unchanged because the only update was just to output the bucket name here. You can see all the output by running this command in the terminal. Pulumi stack output. You can see there's only one output, the bucket name, and then it has the value of it right here. Now we can run the AWS CLI to list the objects in this new bucket. And we can get the bucket name using the command from above. Let me show you how you would do that. So we're going to do AWS S3 ls, and then I'm going to run that command right in here, Pulumi stack output bucket name. So that's going to get the bucket name. And if we run that command, nothing's going to really happen because there's nothing in the bucket. So it's returning what's in the bucket, but there's nothing in the bucket, so there's nothing to be returned. But we'll change that shortly. We're going to now update the infrastructure. We just saw how to create new infrastructure from scratch. So now we're going to make a few updates. We're going to add an object to the bucket. We're going to serve content from the bucket as a website, and we're going to programmatically create infrastructure. This will demonstrate how declarative infrastructure as code tools can be used not just for initial provisioning, but also subsequent changes to existing resources. So we're going to add an object to the bucket. I'm going to create a new directory. I'm going to just go to new folder. I could have clicked this button up here. This folder is going to be called site. And then I'm going to make a new file, and this will be called index.html. Okay, I'm just going to make an extremely simple website here. HTML and body. And then just an H1 tag. And it's going to say, hello, everybody. Okay, now let me rearrange things here. We'll go back to our main.py. And let's add some lines of code so we can add that file to our bucket. So I'm going to add import a new library, the OS library, so we can access stuff from our operating system, the file path in particular. So let's see, actually we'll put it right here. File path equals os.path.join, and then we'll put the directory name, site, and then the file name, index.html. Now we're going to create an object variable, and we'll do aws.s3.bucketObject, index.html. So the object is index.html. And then the bucket is going to be bucket.bucket. And that's how you get the name of the bucket that we created. And for source, I'll put Pulumi file asset file path. So this is how you use Pulumi to get this asset, this file path right here. We're going to create as the object that goes into our bucket. So I'm going to save that, and in our terminal, we'll do Pulumi up, and then I'll just look at this more. Oh, not fire asset, file asset, because this is a file asset. So I'll go to Pulumi up. See, that makes a lot more sense to you, doesn't it, than fire asset. Okay, so you can see it's showing what the change is going to be. We're going to create this object, which is the index.html. We're going to create that. So I will go to yes to do these changes, perform this update. So a single resource is added and the two existing resources are left unchanged. This is a key attribute of infrastructure as code. Such tools determine the minimal set of changes necessary to update your infrastructure from one change to the next. So let's list again the contents of the bucket. I'll just press up a few times. We'll use the same line from before. And now let's see what's in the bucket. It's showing index.html. And if I go back over to my web browser, and if I refresh my page that shows the bucket on AWS, we should see, yep, we see this index.html right here. Next step, we're going to serve content from the bucket as a website. To do that, we'll need to update a few properties. First, the bucket needs a website property that sets the default index document to index.html. That can be achieved by making a few changes to our Python file. We have our bucket right here, and I'm going to, after the bucket name, I'm going to add a comma, and then I'm going to put website equals, and then we just have to set the index document. And we'll just set that to index.html. And make sure that's in a string here. Okay, next the index.html object will need two changes. So let's go down here to see this index.html object that's right here. We're going to need an ACL, which is an access control list of public read. So right after the source, I'll put ACL equals public read. There, now you can see that better. This makes it so it can be accessed anonymously over the internet. We also need a content type, so it's served as HTML. So for the content type to work, let's go back up to the top. We're going to import something, import MIME types, because we're going to set the MIME type. And then down here, after the file path, we're going to get the MIME type of the file. So MIME type, and what we'll put an underscore because this is going to return two things, but we only need one of the things, which is the MIME type. So we'll do MIME types dot guess type, and we'll guess the type of the file path. And now down here, we can set the content type to the MIME type. So now we have the content type, so it's served as HTML. We'll also need to export the resulting bucket's endpoint URL so we can easily access it. So let me show you how you would do that. So here we're exporting the bucket name, and now let's export the bucket endpoint, the full URL. So we'll do pulumi.export, and this will be called the bucket endpoint. We are going to use this concat function from Pulumi to concat a string and something else. So this bucket.bucket, it's actually an object. It's not a string, but it does return a string. So if we want to combine something like this with a string, we have to use concat. Let me show you how that's done. We're going to do pulumi.output.concat. And then I'm going to put the two things we're going to concat. The first thing is going to be a string, HTTPS. Can't even see what I'm writing here. Let's see if I can HTTP. Well, let's do HTTP : / and then we'll get a comma here, and then just bucket.website endpoint. So we're just concatenating the HTTP and this website endpoint. Okay, let's deploy the changes. So, well, let me save it, and then we'll do Pulumi up. If I go up here, we can see it's making some updates, and I'll go to yes. Okay, now we have this URL here. So we can use this to access that index.html file. So I can actually just copy this URL stored on Amazon AWS, and now I can open up the URL right in my web browser. It says, hello, everybody. I can also use curl to get it. So back in my terminal, do curl, and now I am going to run a command right here to get the website URL. Pulumi stack output, and then you can get any of the things that get output, and we'll get bucket endpoint. Okay, see, we got this. Here's the text of our HTML file. Next, we are going to make the stack configurable. Right now, the bucket's contents are hard-coded. We're going to make the location of the contents configurable and add support for populating the bucket with an entire directory's worth of contents. So the next step is to add a config variable. Right now, we hard code the directory of the site. Let me show you here. So we're hard coding this directory here of the site. So we're going to configure it to make it easy to change the location without editing the program. So right below the imports here, I'm going to do config equals pulumi.config. That's going to make it possible to access some config settings that we set up. And we're going to specifically access the site directory, and we're going to get it from config.require, and then we're going to get the site dir. And I see that I spelled Pulumi wrong. There we go. And we are going to set this in a minute, the site directory. But first, let's update our program to use this site dir variable. So instead of getting the site here, I'm just going to paste in the variable name. Okay, so now what we're going to do, I'm going to save this, and then I'm going to go back into my files. I'm going to rename this site directory. I'm going to rename it www. Now, you may not actually do this in like a real life situation, but we're just doing this as an example to see how this can be helpful. So let me go into my terminal, and I'm going to do Pulumi up. Okay, it's saying error, missing required configuration variable, this site dir variable. And it says, please set a value using the command Pulumi config set IEC lab 1 site directory with the value. So that's what we're going to do now. I'm just going to copy this command here, and then I'm just going to paste it in, and then I'm going to set it to www. So now the directory you'll be looking for is the www directory instead of the site directory. Okay, I'll just do Pulumi up again. And I will perform the update. Okay, that works. So now we don't have to have the directory hard-coded in here. We can use these config variables. And you can see how you'll be able to use that with other types of data as well. Okay, now we're going to add more files. Instead of hard-coding the set of files, which we do now, let me show you what I mean. Right now we hard-code that we're adding the index.html file to our bucket. But instead of doing that, we're going to change the program to read the entire contents of the www directory and add every file from that directory to our bucket. So let's start by adding a new file to that directory. So I'm going to go into the directory and click the new file button, and this is going to be called about.html, and this is just going to be a simple thing. You can make it anything you want. I'm just going to make it an extremely simple file with a paragraph. It will say it's about, so I want to say something about me, and I am not a cat. So that's something about me. Okay, let's go back to the main.py file, and we're going to replace the object allocation code And now we are going to update the object allocation code. So this right here, we're going to put all of this into a for loop. So I'm going to say for file in os.list directory site directory. And then I'm going to just indent all of this so it's all in that directory. And see, we have the file here. So now instead of index.html, I'm going to put this variable file. So now we are using this for loop to go through every file and adding all those files to our bucket. Now this is one of the really cool things about infrastructure as code and using an actual programming language like Python is that you can use for loops, and that can make things go that can make things a lot simpler and save a lot of time. Like, we didn't have to use a for loop, we could have just copied and pasted this code a bunch of times and then added each file individually instead of using this for loop. But this is going to save us a lot of time, especially if we have tons of files that we want to put into our bucket. So let's go back to the terminal. Actually I have to save first here, and then I'll do Pulumi up. So you can see what it's going to do. It's going to create this file. This is about.html, and let's do that. I'll go to yes. Now I'm back in my web browser. I'm just going to put a /about.html at the end, and now we can see I'm not a cat. I can zoom in on that so you can see a little better. It's just a paragraph tag, so it's pretty small. We can also access it through curl the same way as before. Let me just press up in here, but I'll just put /about.html at the end. And then, yep, here it is. Here's that about.html file we created. Now we're going to create a second stack. It's easy to create multiple instances of the same project. In Pulumi, each instance is called a stack. This is useful if you have multiple development or test environments, like staging versus production, or if you want to scale a given infrastructure across many regions. So let me show you how to create and configure a new stack. We'll create a stack named prod. So I'm still in the terminal down here. I'll do Pulumi stack init prod. And I just created it. Next I'll configure the two required variables. The same ones we did before. So we'll do Pulumi config set, this is going to be the region, AWS region, and we're going to do it different from before. This time it's going to be EU West 1. You can basically set this to any AWS region. We'll also set the site directory. Pulumi config set IAC lab 1 site directory. And instead of the www, this is going to be www prod. I'm just showing where you can have different site directories for different projects, for different stacks. So let's see the list of stacks we have. Pulumi stack ls. We have the dev stack, and we have the prod or production stack. Now let's populate the new site directory. We could have used the existing www directory for the site directory, but for this example, we'll use the www prod directory to demonstrate how it can be configured. We will make a directory, www prod, and then I'm just going to create a file right from here. We could have created the directory from here. So where's our new directory? Right here. I'll just create a new file, and it's just going to be another index.html file. And we'll just make it pretty similar. I'll just copy this other index.html file, but this time we're going to add a paragraph tag here and put in production. So then we will be able to know the difference between the production one and the development one. So I'll just save that, and then we'll just deploy the changes. Pulumi up. We don't need that up anymore. it says we need to set the configuration variable. Apparently this got set wrong. Oh, it's because I called the site. I made a mistake a long time ago, where it says site.dir, which should have been site.dir. So let's just go back over here and let's see. This is supposed to be site.dir. And I must have, yeah, so now let's try this. Pulumi up. And then I'm actually going to also have to create the site.dir configuration variable for the development stack. But we're on the production stack now, so we'll just keep going with this. Okay, so we can see the new buckets, new objects it's creating, and we can go to details just like before, and you can see additional information, but I will just go to yes and perform the update. Okay, let's try going to this URL here. I could command click, but I'm just going to copy it. And then I'm going to go to my website here. Hello everybody, in production. So we're now seeing the production website. We can also curl it just like before. It's actually pretty much the same command. So if I just press up a few times, and we see hello everybody in production. And especially when you're practicing, whenever you get to the end of what you're doing, you want to destroy everything, destroy the resources. This is especially important in AWS. You don't want to accidentally be charged something if you have stuff on AWS for a long period of time. So to destroy all the resources, we can just use Pulumi destroy. And that will make sure everything gets destroyed. Just like before, it's going to show us a preview, and it's showing that it's going to be deleting all these things. 3 to delete. And yes, I want to do that. And then you'll see this message on the bottom. The resource in the stack may have been deleted, but the history and configuration associated with the stack are still maintained. If you want to remove the stack completely, run Pulumi stack remove prod, which we do want to do. So Pulumi stack remove prod, and I'll just type in prod to remove that. But remember, we have another stack. We have the dev stack, so we're gonna have to switch back to the dev stack using Pulumi stack select dev, and then once we've went back to that stack, we can do Pulumi destroy, and then I will say yes, we want to destroy that. And then we want to run this other command again. Pulumi stack remove dev. And type in dev. Okay, let's just verify that the stacks are gone. So I'll do Pulumi stack list. And there are no stacks. Okay, we just completed the first lab. The next few labs are a little shorter and demonstrate some more advanced tasks. The second lab is all about provisioning EC2 virtual machines. Amazon Elastic Cloud Compute, also known as Amazon EC2, is a web service that provides secure, resizable compute capacity in the cloud. It's designed to make web-scale cloud computing easier for developers. Amazon EC2's simple web service interface allows you to obtain and configure capacity with minimal friction. So in this lab, you'll first create a single EC2 virtual machine. Afterwards, we'll scale that out to a VM per availability zone in your region, and then add a load balancer to spread load across the entire fleet. Now we could do it all within the directory we already created, and just update our Python file, just remove everything from our Python file and start from scratch. But we'll create a new one to get more practice. We'll create a new directory to get more practice. So let me create a new directory called IAC Lab 2, and I'll go right into it, cd IAC Lab 2. And then I'll just open that with my code editor, in this case Visual Studio Code. And before I initialize the project in the terminal and then switch over to the code editor, Now I'll just initialize the project right from the terminal within my code editor. So let me open up the terminal, and we'll do Pulumi new AWS Python. So this is a little different from before. Why? Now we just have to make sure our virtual environment is set up. So I'll do Python 3 venv, and then source venv ben activate. Let's try putting an E at the end. That works better. Okay, now let's install the requirements. And let me configure the AWS region. So Pulumi config set AWS region US West 2. And again, you can use any region for this. Okay, you can see the files here are pretty much the same as before. We have the requirements, we have the YAML file. Move this down. In the main.py, you can see this is a little different. We've already initialized this with creating a bucket and exporting the bucket. You can see the way we created this with the Pulumi new already added some extra code creating an S3 bucket. I'm going to do this a little differently, so I'm actually going to delete all of this, and I'm going to import Pulumi AWS as AWS. Now we're going to dynamically query the Amazon Linux machine. We'll do this in code, and so that will avoid needing to hard code the machine image. In other words, it's AMI. AMI is the Amazon machine image, and that provides the information required to launch an instance. So let's get the AMI with code. So AMI equals aws.ec2.get AMI. And we want to get the most recent one. Okay, you can barely see that. Okay, so most recent, we can set that to true. And then I'm actually just going to paste in some stuff here. Everything's in the description, all the code and everything. There's a link to an article that will have all this code. But this allows us to set the owner of the AMI and some filters we want to use. So we also need to grab the default virtual private cloud, which is a service that lets you launch AWS resources in a logically isolated virtual network that you define. That's available in our AWS account. So to get that virtual private cloud, we'll just do VPC equals aws.ec2.get VPC. And then we'll just set the default to equal true. Now we'll create an AWS security group. This will enable ping over ICMP and HTTP traffic on port 80. So for this, I will just paste it in. And we can see this is how you would create a security group on here. And again, you can get that code right from the article in the description. Now we're going to create a server. And the server is actually going to have a startup script that spins up a simple Python web server. I'm just going to paste in some code and then I'll explain it. So we're creating an instance of the server, we're creating a web server, and then this is the type, a t2.micro, and this comes right from AWS, the types of different servers that you can create. So you could do a T3 or T1, and there's just different types you can do. And then we're getting the security group IDs right from what we already created up here, the group IDs. And then the AMI is from what we already created. And then this is an interesting thing, the user data. Here, we are creating a simple Python web server. Now, for most real-world applications, you would want to create a dedicated image for your application rather than embedding the script in the code like this. But for this example, we're just trying to spin up something really quick. Okay, now we are going to export the EC2 instances resulting IP address and host name. So we'll do pulumi.export, and then we're going to export the IP, and then server.public IP. We're getting the IP is coming directly from AWS here, and then the host name. which in this case is the public DNS. Okay, we're going to provision the EC2 instance and access it. So to provision it, we'll do Pulumi up. Wait, first save, and then Pulumi up. And then let's see what it shows. Looks like there's an error. I think we made a minor mistake here. Oh, API, that should be AMI. So let's save that, and then do Pulumi up again. Okay, and you can see it's showing what it's about to create, and I'll just go into yes. Okay, if we go up, we can see we have the host name and the IP address. So I'm actually just going to take this host name and I'm going to copy it, and we're going to go right into our web browser. So if I paste it in here, okay, it took a few seconds to start working, but it must have finished provisioning. So it says, hello world. And another way to do it is right from the command line. Interestingly, it looks like a new version of Pulumi must have came out in the middle of me making this tutorial, because it wasn't saying that before. Okay, but right now, I'm going to do this. Curl and do Pulumi stack output hostname. And then we can see the hello world right here. And I might as well just install the new version of Pulumi while I'm at it. Okay, that was simple. So the next thing we're going to do is add more EC2 instances. We're going to create multiple EC2 instances that are each running the same Python web server, and we're going to make them across all AWS availability zones in the region. So let's go back up to our code. And the part of the code that creates this web server and this instance, and it exports the resulting IP address and host name, we're going to modify this a bit. Well, first of all, we're going to make there's going to be a new IP and host name for each AWS availability zone. So let's store those in an array or a list. So IPs equals, and then we're just making an empty list that we're going to be filling. Host names equals, and then we're going to put this into a for loop, because we're going to make an instance for each element for each availability zone. So for AZ in AWS dot get availability zone, we can get right here. Dot names. So for each availability zone, now what I'm going to do, I'm going to put this into the for loop, and then we'll just do some minor updates. So this will be different for each availability zone. So for where it says web server, I'm going to use a Python f string to put a variable in here. Dash AZ, which is the availability zone. And then for the, well, we'll add what the availability zone is. So I'll put availability zone, and it's just going to be AZ. And now we are going to make it so we're going to make it so where it says hello world, we're going to make it so this is different. The index.html file is going to be different for each availability zone. So for that to work, let me just add a few characters here. And then we'll just do .format. Okay, so now it's going to fill in the availability zone in this spot here in the index.html file. And then we'll go down here, and the IP is going to be IPs, and then we'll use that variable. And actually, we didn't fill that variable yet, so we still have to do that. So host names. And then right here, still in the for loop, ips.append server.public IP, and then host names append server.public DNS. Okay, so now we'll be exporting the list of IPs and the list of host names. So let's do another Pulumi up. I'll save that, and we'll do Pulumi up. Okay, so we're going to be deleting our original one and creating 4 new ones. If we go up here, so there's 4 of them for each availability zone, and you can see them right here. West 2A, 2B, 2C, and 2D. So I'll perform that update. Okay, it looks like we have an error. The requested instance type, which is t2.micro, is not supported in the availability zone, but just this one. So I'm going to copy this, and we're going to use an if statement to make sure we create an instance everywhere except that availability zone. So if not AZ equals US West D2, then we'll create the server. Okay, let me just indent all of this here. And then I'll save it. Pulumi up. And I'll go yes. Okay, now we have these 3 outputs. So I can just try going to 1 in the web browser. And you can see this one is in 2A. Let's try another one. And this one's 2B. So each web server is going to include in the response what availability zone it's in. But this isn't very realistic. In the real world, you're not going to want all these different URLs for each availability zone. We're going to now add a load balancer. The load balancer is going to be able to distribute the load evenly. We'll just have a single URL that we can go to, and the load balancer will automatically determine which server or which availability zone to get the data from. This is the way you can handle a lot of people going to a website at once, and the website can be loaded from different places depending on where the load is the lowest, so it can kind of balance the load across all the servers. Okay, back over to our code, we need to add an egress rule to our security group. Whenever you add a listener to your load balancer or update the health check port for a target group used by the load balancer to route requests, you must verify that the security groups associated with the load balancer allow traffic to the new port in both directions. So, to do that, I'm just going to paste in the egress here. This is required to ensure the security group ingress rules don't conflict with the load balancers. So now we'll define the ALB. Let me go right after this security group definition. I'm going to add the load balancer creation steps. So I'm going to just paste in some code here and then I'll go over it. So we already got the VPC up here, but we also need the VPC subnets. And then we're going to create the load balancer like this. Its internal equals false, so it can be accessed by the public. We're going to use the group ID for the same security groups, and then the subnets we get right up here. And then we're creating a target group here. And then a listener. So we've defined the ALB, its target group, and some listeners, but we haven't actually added the EC2 instance to the ALB. So this is how we're going to add the instance. Let's go down to our creation of the EC2 creation. We'll just update this to just security groups. And then we'll attach the instances. So we'll do attachment equals aws.lb.target group attachment, and then this f string here. Target group ARN is going to be the target group .arn, and the target ID is going to be the server.private IP, and then it's going to be on port 80. Okay, we just want to export one more thing. the URL, and this is going to be the main URL we're going to be using, which it has the load balancer. Okay, this is all the infrastructure we need for our load balanced web server. So I'll just save that and we'll apply it with Pulumi up. And I'll perform the update. Okay, here's the load balancer URL. If I just copy this and I'm going to do a curl to it. Now watch, I'm just going to keep doing it a few times, and every time I do this curl, you can see that a different URL is loaded, because see, it says US West 2A, 2C, 2B, 2B, 2A. So the load balancer is working. I have one URL, but each time I go to the URL, it's being loaded from a different server because the load is being distributed. So that works. That's how you create a load balancer with infrastructure as code. Since we're done with that, I'm now going to destroy everything. Since this is just a test, I don't want these web servers still going on AWS. So to destroy everything, I'll just do Pulumi destroy. And then I have to see, do I want to delete all this stuff? Yes, I do. Okay, and just like it says here, we can also run this command, Pulumi stack remove dev, to remove the stack completely. In this final lab, we'll use Pulumi to deploy a Docker image to ECS with Fargate. So let's start from the beginning again to make more practice. So let me go out of this directory, and I'm going to create a new directory. And then I'll just change into it. And I will initialize the project. Okay, we'll do Pulumi new AWS Python. And then I'll just fill this in or just hit enter to use the default. So just like before, it's creating all the files we need. It's initializing a new stack named dev, which is an instance of our project, and it's installing the needed package dependencies from PyPy. Let's open up this in VS Code. Okay, here's the project in VS Code, the same files from before. We have the main.py, which is going to be our main file where we put all the Python code like before. And you can see down in the terminal, we're in our virtual environment. And let's configure the AWS region. Now it did do that when we were setting things up, but just to make sure we have the right region, Pulumi config set AWS region US West 2. And then we'll go back up to our code, and I'm actually just going to delete a lot of this because we're going to start from scratch. We're going to start by creating an ECS cluster. So we imported Pulumi. Now let's import Pulumi AWS as AWS. And now we'll create a new cluster. We can use the default values, so it's going to be pretty concise. So cluster equals aws.ecs.cluster cluster. Now we're going to create a load balance container service. So we're going to allocate the application load balancer, or the ALB, and listen for HTTP traffic port 80. In order to do this, we'll need to find the default VPC and the subset groups for it. Okay, I'll just paste in some code here, and then we'll just look through it. I'm going to go through it pretty quick. A lot of it's similar to the last lab we did. So we create the VPC and the VPC subnets. We got the security group here. There's the egress, and then we got the load balancer and the target group and the listener. So I'll save that and run Pulumi up. And then I'll make the update. So we've fleshed out our infrastructure and added a load balancer that we can add infrastructure to. In the next step, we'll run a container. AWS Fargate is a service that enables a user to run containers on Amazon's cloud computing platform without the need to manage the underlying infrastructure. In order to create a Fargate service, we'll need to add an IAM role and a task definition in service. The ECS cluster will run the Nginx image from the Docker Hub. So we're not actually going to create our own Docker image for this example. We're just getting the image right from Docker Hub. So first we'll need to add an import at the top of our file. I'll go to the top and put import JSON. Now at the bottom, I'm going to paste in some more code here. Again, it's all in the description if you want to get the code. So here we define our IAM role and attach a policy. So this section right here, we're defining the role here. And then we're going to attach this policy. Then we define a task definition for our ECS service. You can see the image is the Nginx image. And then here is the service. And then at the very end, we export the URL. We get from here the ALB, the DNS name. So let's provision the cluster and service. I'll save, and then do Pulumi up. This is going to output the status and resulting load balancer URL. Perform the update. So if I pull this up, we can see the status and the resulting load balancer URL. I'm going to copy this URL, and we're actually going to try going to it in the web browser. So if I load this, it says service temporarily unavailable, but let's see if I refresh it a few times. Okay, if I keep refreshing, it eventually says, welcome to Nginx. We got the web server. It says if you see this page, the Nginx web server is successfully installed and working. We can also go to the terminal and do this curl Pulumi stack output URL. So it's just going to actually just curl that URL. And you can see we have the same HTML that we saw in our web browser, that the Nginx web server is successfully installed. So now let's update the service. We're going to change the desired count from 1 to 3. So now we are making 3 containers. Save that, and then I'll do Pulumi up. And then I'll say I want to update. I'm over on the AWS console, and if I go to the ECS clusters page and I make sure I have the right region in here, the one that I set up for my on Pulumi, we can see the cluster that I created. We have one service, it's running 2 tasks. So desired task 3, and it's running 2. So we can see the desired count up here is 3, just like we set up in Pulumi. Okay, we're actually done with this. So we're going to destroy everything. Pulumi, destroy. And yes. Okay, and then we'll remove the stack completely with Pulumi stack remove dev. Okay, we're done with the 3rd lab. Thanks for watching, and I hope this spurred your interest to start trying to use some infrastructure as code on some of your own projects.